This is a recording of how to set up the Excel spreadsheet for the chocolate game that we play in the first week of class, and we study this in session 26. This is the Excel template that you have available on Blackboard. The numbers in the yellow cells correspond to the parameters of the problem that are given to us. In columns B, C, D, E, F, G, H, and I are the possible values of each customer's willingness to pay. And in the second row immediately below it correspond to the probability that the willingness to pay is equal to each of the 8 possible values. And these numbers sum to 1 because these are probability mass function. The numbers in the third row correspond to the probability that the willingness to pay is greater than or equal to each of the 8 possible values. Okay. And the numbers in the fourth row represent the complement of it. Okay. So it's the probability that the willingness to pay is strictly less than a particular value. And finally, the number in the fifth row represent the immediate expected revenue that we would get if we set the price at each of the 8 possible values. And this number is simply computed by taking the price multiplied by the probability that the customer's willingness to pay is at least that price value P. So all these numbers are given to us as part of the problem. And the value function V1 with 1 customers remaining, as noted in our lecture, when you only have 1 customers to go, the value function or the maximum expected reward that you can get is simply a myopic reward. Okay, so you simply set the price that maximizes the immediate revenue, and that would correspond to 5.81. So now our goal is to fill in these value functions. Okay, and as you've seen from this template here, we have set up the area for computing the Q functions for various different decisions. So the goal here is once we want to be able to just enter the formula once and use copy and paste function in Excel to extrapolate the formula. So let's start by computing Q2 of X associated with taking the decision of setting the price at $5. So let me enlarge the formula box to have a few more rows. Okay, so the value of Q2 at X equal 1 associated with setting the price of the chocolate box here at $5 will consist of the first component would be, as always, the immediate expected reward. Now the immediate expected reward of setting the price at $5 can be computed by looking up the table at the very top of our Excel spreadsheet. And we can do that using an HLOOKUP command. So we're going to look up the immediate expected revenue associated with setting the price at $5. So here's the value that we're looking up, and I'm going to anchor that. And the area, the table where I'm looking this value up, here is going to be this shaded area, and I'm going to anchor everything because that table will always remain fixed. And the row where the immediate expected revenue is recorded, that's going to be row number 5 of this table. So I can hard code that in there. And then we want an exact match, so that's going to be false. Okay. So this term here represents the immediate expected reward that we get from setting the price of the chocolate box at $5. Now we're going to account for expected future reward. So let me enter a new line using Control Alt Command Enter in Mac, or just Alt Enter in Windows. So for the expected future reward, there are 2 scenarios. Okay, in the first scenario is that the customer's willingness to pay end up being less than $5. Okay. So in that case, that happened with probability equal to the probability that W less than P, and that's given in the fourth row of the top table here at the top of our Excel spreadsheet. So we can do an H lookup. Okay. Looking up again at $5, same value as before. We're looking up the same area here. And we're looking now for the probability that the customer's willingness to pay is strictly less than the price. So this is going to be in the fourth row, okay, and we want an exact match. And when the customer's willingness to pay is less than the price of $5, we will end up with the same amount of inventory as we have before, which is in this case X equal 1. And the value of having 1 unit of inventory going into the future, meaning we have with 1 customers remaining, is going to given by the value function v1. Okay, and we can get that by do a VLOOKUP. We're looking up the value at the current inventory. There's no because the customer's willingness to pay is less than price, so no sales take place. And I'm going to anchor column A. And the value function is located in this brown shaded region. I'm going to anchor everything except column B because I want that column to extrapolate as I copy this formula. And the location of V1 here is the second column in this array, and that index here is given by this cell C7, which I'm going to anchor the row, and I want an exact match. So this second term here in the second line represent the expected future reward if the customers end up having a willingness to pay less than $5. In that case, no sales take place. Okay, so and then we're gonna have the last term. So enter a new line. It's also which account for the fact that it's also possible that the customer's willingness to pay end up being greater than or equal to $5. And in that case, this happened with probability given by the third row of our table here. So we're going to do exactly the same thing here. So we're going to look up the value of B21 of $5 from the top part of our array, A1 through I5, anchor that. And the probability that the customer's willingness to pay is at least greater than or equal to the price of $5 here is given by the third row. And we want an exact match. And in this particular case, we'll move on to the future, meaning going to this with 1 customer's remaining, would now have 1 less unit of inventory because the customer would have purchased the amount of chocolate box that we have. So and the value of that is going to be VLOOKUP. Okay, so our inventory now is no longer A24, but rather A24 minus 1, because you have 1 less box of chocolate. And the value of that, again, is the same as before. It's going to be in this brown shaded area. Okay. Going to anchor everything except the column B. And we're going to look up the second column, which is in C7, and false. Okay, to get an exact match. So that is the complete formula. Okay. Hit enter, and that gives us the value. So now let's copy and paste. So I'm going to do copy. I'm going to grab the entire array here and paste. Okay. So let's double check to make sure it's referenced the array references are correct. Okay, so everything looks good. So right now we can then copy and paste to the next section on Q, the Q function associated with setting the price as 7. Okay, so now everything, all the references are correct. The only difference here is that all of the references to B21 here should be changed to B35 to reflect the fact that here we're taking the decision of we are setting the price here, immediate decision at $7. So it should be B35. Okay, I'm going to change this as well to be 35. And that's it. Again, copy. Grab the entire array here and paste. And then we're going to continue this process until we fill the entire Excel spreadsheet. So we've now copied all of the formula there. Now all we have to do is now compute the value function. And as noted in the lecture, the value function is simply the maximum of the Q values, the corresponding Q values. Okay. So V2 of X, so with V2 with the value maximum expected reward that we can get with 2 customers remaining and 1 chocolate box to go, X equal 1, is simply the maximum of the corresponding Q values for different decisions. So Q2 for X equal 1 at $5, Q2 for X equal 1 at $7, $9, at $11, 13, 15, 17, and 20. And that's it. Okay. The maximum of the 8 terms corresponding to the 8 different price levels that we can set. And that will give us the value. And then we can copy and paste. And that gives us the desired value functions. Now, to finish up this Excel spreadsheet, we need to compute the optimal decision. So the optimal decision, in this case the optimal price that we should charge in each possible state of the world, well, we simply look at the value the decision that gives us the maximum expected reward. And a simple way to do this here is to compare. First, check if the value function here, C10, okay, which is the maximum, if this maximum value equal to the value from setting the price at $5, okay, which is the Q of X equal 1 associated with $5. In that case, we are going to set the price to be 5. Okay? So that's the first case. But it's also possible that the maximum corresponds to setting the price at 7. So we're going to test for that. Now let's enter a new line here. If C10 equal to the value from setting the price at 7, which is here, Q2 of X equal 1 and price of $7. In that case, well, the optimal decision is going to be to set the price as 7, and I'm going to anchor that. I'm going to continue in this fashion. There are 8 different cases to consider. The third case is to check if this maximum value corresponds to setting the price at $9. This is the maximum expected reward that we get from setting the price at $9. If this is equal to the maximum among all the 8, which is the value computed in C10, then the price that we're going to set here is $9 here. In this particular case, one of these 8 conditions must hold because the value at C10 here is really the maximum of these 8 values, C24, C38, C52, C66, C80, C94, and C108, and C122. Okay, so one of these 8 if condition must hold. So it's not possible that none of these hold, and if that happened, I'm just going to have a little error checking function here. I would just say, if none of these 8 conditions hold, there must be an error, and something would be wrong. Okay, so that should not happen, okay, and that's pretty much it. So we're going to have 8 right parentheses to close this off. 1, 2, 3, 4, 5, 6, 7, 8. Okay, and then we simply copy and paste.